on those YouTube channels, we're talking about vectors and scalar quantity under physics. First, we have to understand that scalar quantity are quantities that have magnitude, but they do not have direction. They have magnitude or no direction. Examples are mass, distance. We have length. Length, my idea that this is the length. I'm not telling you that okay, this is the length to the right or to the left. Distance, anything I can tell you that a man walked a distance of 5 kilometers, but I'm not telling you to which direction. Then we have speed. Speed and another speed now, but I'm not telling you that I have speed to the north or that or that. We have time, we have area, we have volume, we have temperature. Obviously, temperature does not have direction. We have pressure, we have density, we have power, we have energy, we have work. Just know that these brothers, power, energy, and work, they are under the same topic. They are all scalar. Pressure and density. We're talking about this in our next video, pressure and density. They have some relationship together that we're talking about. Then we have electric charge and electric potential. So that's about that. We also have vector quantities, and vector quantities are quantities that have both direction and magnitude. Unlike scalar that do not have direction, vector quantities have both direction and magnitude. Example are weight. Now, don't get it wrong. We have made videos about mass and weight. Weight is different from mass. Weight has direction, and the formula of weight is NW equals to mg, which is mass and gravity. Acceleration due to gravity. Acceleration due to gravity. So it has a direction. For instance, now you are choosing matter of the force acting on it is what? Gravity. So this is direction. This is weight and having direction. We have force, which is what? MA. Mass times acceleration. Acceleration is having direction. We have displacement. So the difference between displacement and distance is that now there are some questions in physics jamb that we say, for instance, a man walked 5 kilometers due east, then turned maybe 15 kilometers due west or east. So displacement will tell you that this is the particular place that this man is going. Guys, don't get this wrong. Don't get this wrong. Distance is different from displacement. Velocity is different from speed. Yeah, velocity is having direction, but speed does not. We have acceleration. Acceleration is what? Formula for acceleration is velocity over time. Yes, the formula for acceleration is velocity over time, and the SI unit is what? Meter per second square. So that's that on that. We have momentum, and whenever you see momentum, in case impulse is also what? Impulse is same thing as momentum. So momentum and impulse, they are under vector quantity. We have moment in equilibrium, we have stopping, we have electric field, not electric charge, not electric potential. Electric field is an area where electric force is felt. So this area now is a particular direction. Maybe the electric field now is going to this area. You get what I'm saying? But potential or the charge is not what? The plus and minus. So it does not have direction. Why electric field has direction? We have magnetic induction and we have magnetic flux. So let's quickly move over to the other part of the practice question. So let's move to the practice questions under vectors and scalar quantity. Now, first question is saying what? An example of scalar quantity is what? Which means that which of the following does not have direction but possesses magnitude? Now, if we check the first option, we have velocity. Option B, we have weight. Option C, we have electric charge. Option D, we have acceleration due to gravity. And option E, we have momentum. Now, if we check the first one, velocity is obviously having direction. According to what we have known already, velocity is having direction, so it is not the correct answer. We move to weight. Weight, not mass. Not mass in this case. Not mass in this case. So weight is also not having direction. We have electric charge. Obviously, electric charge should be the answer. Electric charge as the answer. Then let's check the other option, because this is electric charge, not electric field. and the constant equals to 9.8 meter per second. So that is also a vector quantity. We have momentum, or if you see impulse, they are both vector quantity. Now, our correct answer will be electric field, as momentum is a vector quantity, weight is also a vector quantity, acceleration due to gravity is a vector quantity, and momentum is also a vector quantity. So the correct answer is option C, electric charge. Moving quickly to number 2. Number 2 says what? Which of the following is not a vector quantity? Which means that which of the following is a scalar quantity? We have A, force, B, altitude, C, weight, and D, displacement. So we already know out of these options that force is a vector quantity. Abi? Now we want to use the elimination method because we are not sure what the answer is. We want to check the one that we already know as vector quantity. So option B, altitude, we have not been taught, so we don't know. Now option C is weight. Abi? Weight is also a vector quantity. We cancel it out. Then we have displacement. Displacement not distance. Assuming this was distance, it will be our answer, scalar quantity. So we also cancel out displacement. Leaving altitude here. Now altitude is just is not having direction. Altitude does not have direction. So they said the lower the temperature, the higher the altitude. So altitude does not have direction, which makes altitude our correct answer. Moving quickly to number 3, which of the following are the correct set of scalar quantity? We have I to the electric potential, we have token, we have momentum, and we have energy. Now option A says 2 and 3 only, which means 2 and 3, which are this scalar quantity. Then we have B, 1 and 2, that's electric potential and token. Then we have C, 3 and 4 only, momentum and energy. We have D to the electric potential, I and I, electric potential and energy. So out of the correct answers that we have here, if we check this here, 2 and 3, which is token and momentum, we realize that momentum is a vector quantity and also token is a vector quantity. So option A is out. Then we also have B to be 1 and 2. Electric potential is a scalar quantity, but token is not. So it means option B is also wrong. Then if we pick up option C, momentum and energy. Energy is scalar, but this is vector quantity. So it means option C is also wrong. Then if we check option D, we have electric potential and energy. Any type of energy, if you see kinetic energy, any potential energy, any type of energy, they are all scalar quantity, which means D are correct answer. Moving quickly to number 4, which of the following is a set of vectors? Which of the following are set of vectors? Number 1, we have force, mass, and density. Force, mass, and density. Force is a vector quantity, right? Mass is not a vector quantity. Density, not a vector quantity. So option A is wrong. Now if we go to option B, we have option B to be acceleration, a vector quantity, velocity, a vector quantity, and momentum, a vector quantity. Now let's move towards to option C also. We have mass, which is not a vector quantity. We have weight, which is also not a vector quantity. Which is a vector quantity. And we also have density, which is not a vector quantity. Option D, we have mass. We have mass. Mass is not a vector quantity. Volume. Volume is not a vector quantity as well. We have density, which is not a vector quantity as well. Which makes option B our correct answer. I hope we have gained a lot from this practice question, and that will be all for today under the topic vectors and scalar quantity. Yeah, thank you for today. That will be all under vectors and scalar quantity. Make sure you subscribe to know who is YouTube channel and